Good day to all of you. Today we shall discuss on the topic binary trees. My sincere thanks and acknowledgement to authors Ellis Horowitz, Sarta Sani and Susan Anderson Freed, authors of the textbook with title Fundamentals of Data Structures in C. I have taken the content of whole discussion from this textbook. This topic comes under the subject Data Structures and Applications with subject code BCS304. The trees topic comes in module 3 and continued in module 4. Binary trees is one of the topics in tree topic. A tree in data structure has nodes and links. Nodes means the memory locations which has the data, and these memory locations are linked to one another. So in binary tree, each node can have maximum of 2 children linked to it. Suppose 3 children means that tree is called as ternary tree. If more than 3 means n-ary tree. But to the max, if 2 children are there, and that kind of tree is called as binary tree. In binary trees, we have 4 different types of binary trees. First one, simply binary trees. Second one, full or strict binary trees. Third one, almost complete binary trees. Fourth one, complete binary tree. First we shall see two binary trees. So in trees which have at the most 2 children, at the most means maximum 2 children, means a node may have 0 children, means no children at all, only one child, or 2 children. So this is a binary tree because there is one node, this node has no children, means 0 children, hence it is a binary tree. This is another binary tree because this node has one child. So this is also another binary tree because this node has one child. So this is binary tree because this node has to the max 1 to 2 children, and these nodes have 0 children. And this tree is a binary tree because this node has 1, 2 children. This node has only one child. This node has only one child. Next, if you take up this tree, this node has 1, 2 children. This node has 1, 2 children. This node has 1, 2 children. And all these nodes are the leaf nodes which have 0 children. Hence, if you see to any node in this tree, it is having to the max 2 children. It may have 0 or 1 or 2 children, not more than that. This tree is also binary tree because this node has 2 children. This node has 1, 2 children. This node has only one child, and these 3 nodes have 0 children. And this is also binary tree because this node has 2 children. These 2 nodes, if you see, this node has 1, 2 children, and this node has only one child. And this is also binary tree because any node, if you observe, it may have 0 or 1 or to the max 2 children, because this node has 1, 2 children, this node has one child, 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 and these 2 nodes have 0 children. Hence here all are binary trees because any node in those trees, if you observe, it may have 0 or 1 or to the max 2 children, not more than that. So the next one we shall consider full or strict binary tree. So in strict binary tree, any node, if you observe, it may have 0 children or 2 children. Any node, it cannot have only one child. Okay. So this is full or strict binary tree because it doesn't have any children, so 0 children. And this is also full or strict binary tree because any node, there are 3 nodes. This node has 2 children, and these 2 nodes have 0 children. Hence this tree is also full or strict binary tree. Next, this tree, if you consider any node, this node has 2 children. These 2 nodes have 1 to 2 children each, and all the nodes in this have 2 children each, and all the nodes in this group have 0 children. So any node, if you observe, it is having either 0 or 2 children, and hence this is a strict or full binary tree. Now considering this tree, if any node in this tree has either 0 or 2 children, then only it can be called full or strict binary. This node is having only one child, which is violating, and hence this is not a full or strict binary. But this tree, if you consider, this node has 2 children. Here this node and this node has 2 children, but all the nodes here have 0 children, and hence according to the rule that is having either 0 or 2 children, and hence this tree is called as full or strict binary. Next, this tree, if you take any node, this node is having 2 children, this node is having 2 children, but this node is having 0 children. In this tree, any node, if you consider, it is having either 0 children or 2 children. Hence, this tree, if you consider, it is a full or strict binary tree, because any node, it has either 0 children or 2 children. Lastly, this tree, if you take, this node is having 2 children, okay, but this node is having 0 children, okay, but this node is having only one child. So according to rule, it should have either 0 or 2 children, but it is having one child. So this is not a full or strict binary tree. So in any tree, if all the nodes, if they are having either 0 or 2 children, then that tree is called as full or strict binary tree. Next, we shall discuss on almost complete binary tree. So here left field first, then with 2 children till last level. Okay. So here this node is having 2 children, left, right. So in this level, each node, if you consider, this is having left, right, this is having left, right, till here it is full with 2 children. Then in this level, this node has left field, right field, this node has left field, right field, this node has left field, right field. This node, if you consider, before filling the right, left is filled, it is okay. Hence this is called as almost complete binary tree. Next, if you take up this tree, so till here it is having 2 children, every node, but in this level, this node has left, right, this node has left, right child, this node has left, right child, but this node without filling left, right child is filled, hence it is not almost complete binary tree. Next, if you take up this tree, this node has left, right, both the children. This node has left, right field. This node has left, right field till here with 2 children. But in next level, this node has 2 children. This left, right, this left, right. This has only left. But next level, left is filled without filling in the previous level, right one. In the previous level till there, the node should have 2 children. That is what is the meaning, 2 children till last level. Till last level, 2 children, only it should fill the next level. And in filling left first. So that is the rule. Hence this is not a almost complete binary tree. Next, if you take up this tree, so this node has left, right, 2 children. This node has left, right. Now this node has left without filling right. The next level is filled. Till last level, the nodes are not having 2 children. Hence, this is not almost complete binary tree. Next, taking up this tree, this node has 2 children, left, right. This node has 2 children, left, right. This node has 2 children. Then all these 4 nodes have 2 children. So this level is till here, all the nodes have 2 children. Then only next level is filled. In that left is filled first. So all the rules it is following. So till last level 2 children, and its next level left is filled first. So this is almost complete binary tree. So this last tree, if you consider, this node is having left right 2 children, this node is having left right, then this node is having left, then no right child. Without filling this level with 2 children, next level is filled. We can go to next level only when till last level all the nodes are made to have strictly 2 children. So till last level all the nodes having 2 children, only then next level can be filled, and while filling left must be filled first. So that is what is the rule. So this is not almost complete binary tree, because in last level it is not will filled with 2 children. Without having 2 children in last level, the next level is filled. Hence it is not almost complete binary tree. So that is all about almost complete binary tree. Next we shall discuss on complete binary tree. Here this is not a complete binary tree, because there is one node, it doesn't have 2 children. So by definition, complete binary tree means in a binary tree all the internal nodes should have 2 children, and all the levels should be filled with 2 children. These two conditions. So here this tree, if you consider, these two are leaf nodes. This is internal node. This has 2 children. Hence this whole tree is complete binary tree. Next, if you take up this tree, these are leaf nodes. This internal node has 2 children, and this internal node also has 2 children. This last internal node also has 2 children, and this level is also filled. So hence it is a complete binary tree. Next, this tree, if you consider, here this node has 2 children, this and this node has 2 children, this node has 2 children, and this node has 2 children, this has 2 children, this has 2 children, but this has only 1 children. So one child is missing here. So this level is not filled. Hence this is not a complete binary tree. If you take up this tree, all these are leaf nodes, remaining are internal nodes. This has 2 children, this has 2 children, this has 2 children, this has 2, this has 2, this also has 2, this also has 2. All the internal nodes have 2 children, and this level is also filled, and hence it is a complete binary tree. This example, if you consider, it's a very unique example. So in this, these are leaf nodes, these are also leaf nodes. Here these 5 are also leaf nodes, because leaf node in the sense which have 0 children. The nodes which have 0 children, they are called as leaf nodes. All remaining are internal nodes. Now suppose if you consider this internal node, it has 2 children. This internal node has 2 children. This also has 2 children. This also has 2 children. Okay. This has 2 children. This has 2 children. So all the internal nodes have 2 children. But here there are holes. The last level is not filled. So this is the last level. So that is not filled. Hence this is not a complete binary tree. It's a very unique example. It shows that a binary tree is called complete binary tree only if all the internal nodes have 2 children and the last level must be filled. There should not be any holes here. So that is what is complete binary tree. Next, let us solve some exercise problems. So this tree, if you consider, It is binary tree because to the max a tree is having two children, means it may have 0 or 1 or 2 children. It is having, the node is having 0 children, hence it is binary tree. Strict or full means 0 or 2 children. Yes, okay, it is strict or full binary. So it is not almost complete binary or complete binary. Then this one, if you consider, it is binary tree. Strict or full means 0 or 2 children. So it is not so, hence it is not strict or full. It is not almost complete. It is not complete binary. Why it is not almost complete? So for this node, left is there, without filling right, next level left is filled. Hence it is not almost complete. It is not complete binary because the internal nodes should have two children. So this is having only one child, hence it is not complete binary tree. So in the remaining examples here, the answers are marked. So you can verify with the reasoning as per the corresponding definitions. Okay. And that is the complete discussion on binary trees. That is, what is binary tree and what are the four different types of binary tree. In simple binary tree, any node if you take, it can have to the max two children. Full or strict means any node can have either 0 or 2 children. In almost complete binary tree mean till last level there must be 2 children, then only next level can be filled. While filling the next level, left must be filled first. If these two rules are followed, then it is called as almost complete binary tree. In complete binary tree, all the internal nodes, if they are having 2 children and if all the levels are filled, then that tree is called as complete binary tree. That completes the whole discussion. I hope you understood. Thank you.